Good morning to everyone. This is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. In this mathematics course, Linear Algebra and Calculus, we are going to discuss about matrices and their applications. Matrices play an important role in engineering in various fields like cryptography, wireless communication, computer graphics, image processing, etc. And also, we apply these matrices in solving system of linear equations. Before going to application part, we are going to discuss about various types of matrices and their properties. Now, let us discuss about the basic definitions of the matrices and their properties. Now, what is matrix? Matrix is the representation of data in rows and columns. Generally, the data may be in real numbers or complex numbers or variables. So, we can take the data in numbers or variables. Generally, we denote the matrix by capital letters and the elements of the matrix by small letters. See the example here. The matrix is denoted by capital A. Now, in this example, the matrix A equal to the elements of the matrix are A11, A12, A1n, A21, A22, so on, A2n, AM1, AM2 and so on, AMN. So, these are the elements of the matrix A. So, the matrix is denoted by the capital letter A and the elements of this matrix are by small letters. So, this suffix indicates the position of the element in the matrix. So, the first one indicates in which row and the second indicates in which column. So, the position of the element A11 in this matrix is first row, first column. Similarly, the element A22 indicates in second row, second column. Similarly, AMN lies in this matrix in nth row and nth column. So, these are the horizontal lines is rows and vertical lines are columns. So, first row, second row, mth row and similarly first column, second column and so on, nth column. That means this matrix contains n rows and n columns. So, the next definition is what is the order of the matrix? The matrix contains how many number of rows and how many number of columns is the order of the matrix. So, in the previous example, here we can define the order of this matrix A is n rows and n columns. So, the order of this matrix is given by m by n and we can read it as m by n. So, m is number of rows and n is number of columns. Suppose the matrix A equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. So, this is the matrix A. So, in this matrix, total 3 rows and 3 columns. So, 3 rows and 3 columns. So, number of rows equal to number of columns. Whenever this property is satisfied, then this type of matrix is called square matrix. Similarly, we can define the rectangular matrix as take another matrix capital A equal to A11, A12, A21, A22, A31, A32. So, this matrix contains 3 rows, 2 columns. That means 3 rows and 2 columns. Here the rows is not equal to columns. Number of rows not equal to number of columns. Whenever this property is satisfied, then this type of matrix is called rectangular matrix. We can take another example of rectangular matrix as A equal to A11, A12, A13, A21, A22, A23. So, in this matrix, the matrix contains 2 rows, 3 columns. So, the order of this matrix is 2 by 3. So, here also rows not equal to columns. That means number of rows not equal to number of columns. So, this matrix is also called as rectangular matrix. Next, we define row matrix. So, in this row matrix, we take one example A equal to A11, A12, A13 and so on A1n. So, this matrix contains only one row and n columns C1, C2, C3 and so on Cn. So, in row matrix, number of rows is only 1 and we can take any number of columns, that is n. So, this is 1 by n. Row is fixed. We can take any number of columns, that is n, either 2 columns, 3 columns, 4 columns and so on. So, this type of matrix is called row matrix, only one row. Similarly, column matrix. Take the example A equal to A11, A21, A31, AM1. The order of this matrix is total m rows. First row, second row, third row and so on mth row. So, we can take any number of rows, but the column should be only 1. Here the column is fixed. So, that is 1. So, that is why this type of matrix is called column matrix. So, whether square matrix, rectangular matrix, row matrix or column matrix, all these matrices we can define by depending on the order of the matrix. In matrices, we have various types, that is real matrices and complex matrices. In real matrices, the matrix contains all real numbers. The elements are real numbers. In complex matrices, the elements may be complex. The complex number is in the form of A plus IB. In real number, this imaginary part becomes 0. So, only we take real numbers Aij belongs to R. So, this type of matrix is called real matrix. Here Aij belongs to C. So, first we discuss about the real matrices. Already we have defined different types of matrices depending on the order of the matrix. So, these are all various types of matrices: square matrix, rectangular matrix, row matrix, column matrix. Now, here another definition, null matrix. So, here null matrix is defined as this matrix contains all the elements are 0 elements. The elements are 0 elements. If all the elements are 0, then that type of matrix is called null matrix. So, we can, here this is a rectangular matrix, this is a square matrix, but in both the matrices all the elements are zeros. So, that is why this type of matrices is called a null matrix. The next definition, diagonal matrix. In diagonal matrix, take the example A11 0 0 0 A22 0 0 0 A33. Except diagonal elements. All other elements of the matrix are 0, then that type of matrix is called diagonal matrix. Aij equal to 0 for every I not equal to j. That means A12, A13, A21, A23, A31, A32. All these elements are zeros. So here Ai is not equal to 0 for every I, where I is equal to 1, 2, 3 and so on. And this diagonal matrix must be a square matrix. So the order of this matrix is 3 by 3, or we can say it as simply the order of the matrix is 3. Diagonal matrix, except diagonal elements, all other elements must be 0. This type of matrix is called diagonal matrix. So in this diagonal matrix, particular cases of diagonal matrix are scalar matrix, and unit matrix. So these two matrices are the particular cases of diagonal matrix. That means both these matrices are square matrices and except diagonal elements, the remaining all other elements are zeros, but here the diagonal elements are in this scalar matrix. Take the example 3 0 0 0 3 0 0 0 3. The order of the matrix is 3. Here the diagonal element is the same, that is 3. Here the scalar k equal to 3. So this is not equal to 1. K equal to 3, which is not equal to 1. Whenever k equal to 1, then that type of matrix is unit matrix or identity matrix, that is 1 0 0 0 1 0 0 0 1. If the diagonal elements are 1, that is k equal to 1, then this type of matrix is called unit matrix or identity matrix. In scalar matrix, the scalar must be other than 1. We can take it as either 2, 3 or any scalar. K belongs to R, which is not equal to 1. So this type of matrix is a scalar matrix. So these two matrices are particular cases of diagonal matrix. In this diagonal matrix, we can take another example of diagonal matrix is 1 0 0 0 2 0 0 0 3. Here we can take the different elements of the diagonal elements are 1, 2, 3, but the condition is same except diagonal elements, all other elements are zeros. So these are different types of diagonal matrices, and the next definition we can take scalar matrix and unit matrix, already we discussed, and another type of matrix, that is idempotent matrix. So the property of this idempotent matrix is A square equal to A. We take the matrix A and find the product of A into A. Find the product A into A. Again, this product matrix here we obtain the given matrix A, then the given matrix A is said to be idempotent matrix. Next definition, involutory matrix. A is any given matrix. The condition is if A square equal to I. That means the product matrix the product of the matrix A into A equal to identity matrix, then this property is satisfied, then the given matrix A is said to be involutory matrix. Next definition, nilpotent matrix. Nilpotent matrix, here we are taking A is a square matrix and M is any least positive integer such that A power M equal to 0. If this condition satisfied, then the matrix A is said to be nilpotent matrix and M is the index of the matrix A. So here 0 is a 0 matrix. Suppose the matrix A is any given matrix, A square not equal to 0, A cube equal to 0, A power 4 equal to 0, then here in this case A cube equal to 0. That means here we got A into A. Equal to 0 matrix, that is null matrix, then the matrix A is said to be nilpotent matrix. But here we also got the A power 4 equal to 0, but we take the least positive integer, that is 3. Whenever we get A cube equal to 0, we take the index of the nilpotent matrix is 3, that is A cube equal to 0. So here M equal to 3. So we should not consider this one. So consider the index of the matrix A is 3 and the matrix A is said to be nilpotent matrix. So these are all various types of matrices and their properties. The next definition, symmetric matrix. So before going to define the matrix, symmetric matrix, we define the transpose of the matrix. Transpose of the matrix is defined by interchanging rows and columns. Interchanging rows and columns of given matrix A. Suppose, let us take an example, A equal to 1, 2, 3, 4, 5, 6. Here, the order of the given matrix is 2 by 3, 2 rows and 3 columns. Now we find the transpose of the given matrix. It is denoted by A transpose. Interchanging rows and columns of the matrix A. Here the first row elements are 1, 2, 3. We write these first row elements in first column in transpose. That is 1, 2, 3. So the first row is transposed as first column. Similarly, second row is transposed as second column. That is 4, 5, 6. So this is the transpose of the matrix A and the order of this transpose matrix is 3 rows and 2 columns. 3 rows and 2 columns. Interchanging the rows and columns. So this matrix is called the transpose of the matrix A. Suppose A transpose equal to A. A is any given matrix. Find the transpose of A. Suppose both these matrices are same, transpose matrix and the given matrix are same, then that type of matrix is called symmetric matrix. So this is the property of the symmetric matrix A transpose equal to A. Now consider an example of a symmetric matrix. Take this example, A equal to 1, 2, 3, 2, 4, 5, 3, 5, 6. Now find the A transpose. First row as first column in A transpose 1, 2, 3. Second row 2, 4, 5, second column. Third row transpose to third column 3, 5, 6. So this is the transpose of the given matrix A. Now observe these two matrices. A equal to 1, 2, 3, first row. In A transpose also the first row elements are 1, 2, 3. Second row 2, 4, 5. In A transpose also the second row the same elements 2, 4, 5. The third row 3, 5, 6. In A transpose also the third row elements are 3, 5, 6. So there is no change in the order of the elements. That means the matrix A and A transpose are same. That means here the property A transpose equal to A satisfied. Therefore, the matrix A is said to be symmetric matrix. Similarly, we define another matrix as skew symmetric matrix. So, the property of a skew symmetric matrix is if A transpose equal to minus A. If this property is satisfied, then the type of matrix is skew symmetric matrix. So, take one example. This is a given matrix A and find A transpose equal to the first row is transposed to first column 0, 2, minus 3. Second row is transposed to second column minus 2, 0, 5. Third row is transposed to third column 3, minus 5, 0. So this is a transpose of the given matrix A. Now observe these two matrices A and A transpose. Here the first row elements are 0, 2, minus 3. In this A transpose the first row elements are 0, minus 2, 3. That means the negative of matrix A 0, minus 2, 3. Similarly the second row are minus 2, 0, 5. Here also 2, 0, minus 5. That means the negative of the matrix A minus 2, 0, 5 is 2, 0, minus 5. Similarly, the third row elements are 3, minus 5, 0. Now, in A transpose, minus 3, 5, 0. The negative of the matrix A is minus 3, 5, 0. That means, here A transpose equal to minus A. A transpose equal to minus A. This property is satisfied, then the matrix A is said to be skew symmetric matrix. So, in both the matrices, we have to find the transpose of the given matrix and see whether which condition it satisfied. If it satisfies A transpose equal to A, then the matrix A is said to be symmetric matrix. If the property A transpose equal to minus A satisfied, then the matrix A is said to be skew symmetric matrix. Now, coming to next definition, orthogonal matrix. So, in this matrix also, we find the transpose of the matrix A and find the product of the matrices A and A transpose. Then we obtain the product of A and A transpose is identity matrix. Then this matrix A is said to be orthogonal matrix. So the property of the orthogonal matrix is A transpose into A equal to I. The product of A transpose and the given matrix is identity matrix, or we can take A transpose into A, also identity matrix, then the matrix A is said to be orthogonal matrix. The main important property of the orthogonal matrix is A transpose equal to A inverse. That means we need not to find the inverse of the matrix A by applying the formula A inverse equal to adjoint A by det A. There is no need to find A inverse if the matrix A is orthogonal? Simply we find A transpose. A transpose becomes A inverse. This is very important property of the orthogonal matrix. Simply we find A transpose. It is inverse of the orthogonal matrix. So that is the property of the orthogonal matrix. So these are various types of real matrices. In the next class, we discuss about various types of complex matrices. Thank you.